Good day. This is my calculus video for our performance task in my course Differential Calculus. So let me introduce first myself. I am Razel Joshua R. Manapat. I am a third year math major and I am studying in the University of Santo Tomas College of Education. So I am going to have a tutorial about derivatives. So let's go to the concept part. So how do we define a derivative? So a derivative is what we call the rate of change, or the amount by which a function is changing at one given point. So as we take a look on this, so this is a line, this is a curve. So the point wherein they meet, that is what we call the point of tangency. That point of tangency is what we call the rate of change or the derivative. So these are certain fields of applications wherein we use the concept of derivatives. So first is we use this in the field of geometry, especially in solids. The rate of change wherein how solids shrink or it gets bigger. Next is physics. It deals the rate of change on its especially in velocity and acceleration. Then lastly is finance. So we use these derivatives to determine the marginal cost and other certain formulas that will predict or analyze some business trends in the business world. So why do we need to study derivatives? Is first we use the derivative to analyze a certain function. Then we visualize it based on our analysis and apply these principles learned to problem situations. So what are the mathematical skills needed? First is we have reasoning, so we can figure out the corresponding given. Then we visualize first the problem, so we can have a illustration. Then part of our solution is the algebra. So these are the three main mathematical skills that are needed. So let me first read the problem. So a television camera is filming the lift off of a space shuttle that is rising vertically according to the position. With its equation, S is equal to 50t squared, wherein S is measured in feet or distance and t is measured in seconds or time. So the camera is 2,000 feet away from the launch pad. Find the rate of change in the angle of elevation after 10 seconds of lift off. So here is the illustration. In this point is what we call the launch pad. So the distance from the launch pad to the position of the space shuttle after 10 seconds is 50t squared feet, and while the other one is the distance of the launch pad to the film crew is 2,000 feet. So find the rate of change in the angle of elevation. So this is the angle of elevation. So we're going to solve for it. So let us recall the different trigonometric ratios. So as we recall, tangent is equal to the opposite side all over the adjacent side. So let us substitute. This is the opposite side, this is the adjacent side. So tangent is equal to 50t squared all over 2,000. So to solve for your theta, we move the tangent to the other side of the equation, in which it will become arctan 50t squared over 2,000. Since the derivative is what we call the rate of change, so we apply the derivative in both sides of the equation. So the formula for arctan, since there is an arctan here, we use this formula. So arctan u is equal to du dt all over 1 plus u squared. So here we use the formula. Here we simplified 50t squared all over 2,000 to t squared over 40. So this is the simplified part of the equation before its differentiation. And by the way, we we use the term differentiation, it is defined as the process of using the derivative. So first, let us define what is u. So our u in this problem is here, t squared over 40. Then we get the derivative of u, which is, our constant here is 1 over 40. Then the variable is t squared. So we apply the power rule. So it will become 2t over 40. If we simplify it, it will become t over 20. Then next is we apply the denominator part of the differentiation formula. So that is 1 plus u squared. So again, what is our u? So we just substitute it here. So that is 2 squared over 40. Oh, here it is. So then we just square it. So our equation will be t squared over 20 all over 1 plus u squared, or t squared over 40 squared. Then we solve for it. We substitute it in our calculator. So our answer is 6.9 degrees per second. So as we conclude, when the space shuttle lift off after 10 seconds, the rate of change of its angle of elevation is 6.9 degrees. So I hope you learned something in my tutorial, in my calculus video. So this is me, Razel Joshua R. Manapat, signing off. For more videos, just check it on my YouTube channel for other tutorials. So thank you and have a good day.